Hello everyone. This session I will cover the implementation of linear regression, then ridge regression, ridge Cv regression, lasso regression, lasso Cv regression, ElasticNet regression, ElasticNet Cv regression using Python. Also, we will compare the cross-validation score for all these technique, ridge, lasso, and ElasticNet regression. So as you know that the region, lasso, and ElasticNet, these are the regularization techniques. These techniques we use to improve the accuracy of the model, right? These techniques are used to regularize the linear regression model. So here, first we will discuss the Scikit-Learn code for the linear regression model. In the previous session, already we have built this model, linear regression model for the hours data set. And in the previous session, also we discussed that this hours data set is a non-linear data set, and that's why my linear regression model is giving the less accuracy. Because my data set is a non-linear and we are trying to build the model with the straight line, so the accuracy is less. Actually, the best solution for that hours and risk score data set is what? The polynomial regression. Because polynomial regression is used for non-linear data. So because the given data set in the syllabus problem statement is very small data set, we can't discuss here these ridge, lasso, and ElasticNet technique with that data set. So these techniques are actually designed for the high dimensional data set. So that's why here I will demonstrate these techniques with the help of diabetes data set. So here is the first part. Here we have imported all the required library. So my first library, that is the linear regression library. So here from sklearn.linear model import linear regression, that you know that we discussed in the previous session. Then here we have imported matplotlib library and pandas library. Now we want to implement this model for the diabetes dataset, and diabetes dataset is inbuilt in the Scikit-Learn library. Here I have imported this dataset with the help of this statement from sklearn.dataset import load diabetes. Then to build the model for ridge regression, right? We have imported here library from sklearn.linear_model import linear regression, ridge. Right, linear regression already we have imported, so it is optional here, but we want to compare the accuracy. That's why again it is mentioned here. Then we want to build the bridge model also. Then to calculate the accuracy of the model, we have imported here cross validation score function from the sklearn.model selection. Right, so this is the initial part to import all the library. Then we have fetch this diabetes data set with the help of load diabetes function into the data set variable. So diabetes variable. So this diabetes is the variable name, right, where we are fetching the diabetes data set, right, from this library. Then here we have created the object of linear regression, right? So LR is the name of my object. Then LR score is the variable declared to fetch the score of the linear regression model, right? So cross-val score, here we are passing the LR model, linear regression model, then diabetes data set X variable means my input features, then target variable, diabetes.target, and number of fold, that is CV equal to 10. So here we are printing the score using the print function LR_score, right? So here, if you execute this, because my cross validation score is a k-fold cross validation method where my number of folds are 10, right? My score will, this function will return here 10 different values. So these are the values, right, of 10 different fold. These are the score values. Here inbuilt my score function is, here my by default score function is the accuracy underscore score. By default, here the score function is accuracy. So these are the 10 values of 10 different folds, right? And if you want to see the mean of the score, you can use the mean function. So LR underscore score dot mean. So here is the accuracy of my LR model. Now we will see the accuracy of the ridge regression. So ridge is a regularization techniques, right? So here, as you know, with the help of penalty term, we can regularize the accuracy of the model. So that's why here we need to pass the alpha value. Alpha value is a part of the loss function, right? So here RG is the name of the model, right? Already we have imported this reach library here. Now we are creating object of reach here. So what parameter we need to pass to this reach function here? That is the alpha value. So here the alpha value that we are passing is the 0.005. Student, now this is the part of your research, right? To find the best value of alpha. Find the best value of alpha, which will give you the better accuracy. So here, as a survey, you can pass the different values of alpha one by one, right? And you can find the best value. But here is the cross-validation score function. Here we have created the object of this reach function. Then we are calculating the accuracy of the reach model here. So RG underscore score will have the accuracy of the reach model. So here we are passing RG model, my diabetes data set, you know, the diabetes data set, right? So there are multiple dimensions in the diabetes data set, right? Then here's the number of CVs are 10, right? So here we are printing the score of the reach model, right? And here we are printing the mean of all these 10 values. So if you see these values here, these are the 10 different values of the reach k-fold cross-validation model. So here is the mean value of the reach model. Yes, student, if you observe this accuracy of the reach model, which is better than this linear regression model. The linear regression model has given the accuracy of 46.1962. So if you observe here, this accuracy is increased 46.2758. So there is an improvement in the accuracy because this has happened because of the ridge regression model, and we are passing here penalty term, that is alpha value. Then here is the ridge CV. As we discuss here, we can pass the different values of alpha, and you as a developer, you need to identify the best value of the alpha here. So again, my Python library, right, provides us the beauty of the Python library is what they have also reduced this effort to find the best value by trying one by one different values. So here is the variation of reach method, that is reach CV, where you can pass the multiple values of the alpha at a time. In the one statement itself, you can pass the different values of the alpha, and my reach CV will find the optimal value of the alpha from this list of values. From this list of values, reach CV will take the optimal value of the alpha and will pass to the final model and will display the accuracy. So here the reach CV is similar to the reach, only the main difference between the reach and reach CV is what? We can pass the multiple values of the alpha here, right? So from sklearn.linear model, import reach CV. Then reach RG is the model, object. Then reach CV is my inbuilt function here that we have imported here. Now instead of passing the single alpha value, we are passing multiple alpha. We don't know which is the best value of alpha. So here you can pass multiple values, right, randomly, right, and that you can, then my reach CV will find the optimal value of the alpha and it will return this optimal value. So how you can see this optimal value? So again, there is a inbuilt parameter associated with this reach object. So alpha underscore alpha, with the help of this alpha underscore parameter, you can return the best value of the alpha from this set of values of the alpha. So here we are executing the model, we are fitting the model, reach model, fit diabetes data and diabetes.target. Right. Once you have executed this reach model, you can extract this alpha value. Right. So here we are getting the best value of alpha as a 0.005. Your alpha value, best value can be different also, because this will chosen by the model from this list of values only, that is given by the user only. So again, it is a part of your survey to check which value of the alpha, right, whether it is a decreasing value or increasing value, is giving you the better accuracy, and accordingly you can pass here the multiple values of the alpha. So from this list, my best value is the 0.005. Also, you can create the object of this reach CVs, and also you can measure the accuracy of this reach CV model. So like your reach, right? So here reach CV score is equal to cross validation score reach CV. So here again, my name of the model is what? RG, right? That the same name we use here for the reach. Now it will overwrite here because we have executed this code. Now my model is reach CV here, that we are passing to the cross validation score, and it will measure the values of the score, right, for the reach CV model, right? So here we have printed this score, so it is 0.27 because 4627, which is same as the reach, because my value of this reach is same as this, because my best value of the alpha is 0.005, and here in the reach model also we have passed this value of the alpha as a 0.005, and that's why we are getting the same accuracy here for the reach CV also. So this is about your reach regression model. Now my next model is the lasso regression. In the lasso regression, again we get the improved accuracy, right? So depending on your data set actually, right, you will get the improved accuracy of the model. Now we are talking about the diabetes data set. So here we are importing the lasso and lasso CV from the Scikit-Learn.linear_ model. Now I will show you demonstration for the lasso and lasso CV. So again, the difference between lasso and lasso CV is what? Here, with the help of lasso function, you can pass only single value of the alpha, but with the lasso CV, you can pass the multiple values of the alpha, and from this set of values, it will select the best one, optimal one. So like your reach regression, we have created here object of the lasso. Here we are passing the alpha as a parameter to the function. So here again, I am passing 0.005. For the same alpha value, we will check the accuracy. For the lasso model, my alpha best value may be different, right? So it is your role, student. It is your job now to find out the best value of the lasso alpha that will give you the best accuracy of the model. Now I will show you demonstration for the same value, right? So just we will check whether any little bit improvement is there in the model. So here is we have created the object of the lasso model. Then here we are printing the score of the lasso model, right? So here my object is LS, my data set is diabetes data set, and number of folds are 10, same that we pass to the reach regression model. Right now here we are printing this score, right, and also we are printing the mean of this all folds. So if you observe here, these are the values of the all 10 folds accuracy score, right? So here actually in the score function, cross validation score function, by default my uh, accuracy is the R square. Sorry, here previously I told you accuracy, but here for the linear regression model, my accuracy score function is the R square. That is coefficient of determination. Because my outputs are numerical values, we can't use here accuracy score. So my accuracy function is the R square here. So inbuilt by default, it takes the R square, right? So R square should be close to the 1, right? So 46% accuracy is not actually acceptable accuracy. But just to discuss the regularization techniques, we are using this method here, right? So here now these are the accuracy score R square values of all the 10 folds, and this is the mean of this 10-fold accuracy. So if you compare this with the reach accuracy, the little bit improvement is there. Here it is 46.27%. Now my accuracy is increased 46.28%. Right, so little bit improvement is there because of the lasso. So by changing the value of alpha, you can improve the accuracy of the model also, right? So now we'll see the code for the Lasso Cv. So here we have imported here Lasso Cv, then create the object of the Lasso Cv. ls underscore Cv is the name of my object. So Lasso Cv is my inbuilt class here. So here what parameter we are passing? Alpha. Now instead of single alpha value, we are passing here the multiple alpha value. Right? Then this Lasso Cv will select the best value from this set of values and will pass to the model for the best model. So here we are fitting the model, right? So diabetes.data, diabetes.target. For this data set, we are executing the Lasso algorithm, right, for the optimal value of the alpha. So if you execute this, again here alpha underscore parameter you can use to extract the optimal value of the alpha from this list of values of the alpha. So if you execute this code, you are getting here this 0.005 is the best value for the alpha. Similarly, here you can calculate the score of this Lasso Cv, right? Be using the cross validation score where my object is LSCV, my data set is a diabetes data set, number of folds are 10. So here we are printing the score and here we are printing the mean of the score. So if you run this, you will find this accuracy. My object is LSCV, right? And my data set is the diabetes data set. I hope students you are clear with this. Then next is the ElasticNet data set, ElasticNet regularization technique, right, which is the combination of Ridge and Lasso, right? So here we are importing again inbuilt libraries available for this ElasticNet. So from Scikit-Learn.linear model import ElasticNet, ElasticNet Cv. So first, with the help of ElasticNet, we will try with the single value of the alpha for both the norm, L1 norm and L2 norm, and then with the set of values of this, both the alpha, right, for L1 and L2 norm. So here we are creating the object of ElasticNet. So what parameter we are passing? Again, alpha penalty term, but you know that ElasticNet is a combination of Ridge and Lasso. So we, instead of single alpha value, we need to pass here two alpha value, one alpha value for the L1 norm and second alpha for the L2 norm. So this second alpha, this first alpha is a parameter, right? Here first parameter is the alpha, which is for the L2 norm, that is for the Ridge technique, and L1 underscore ratio is the parameter defined for the representing the alpha value of the lasso technique. So here we are passing 0.8. So for a first, we are passing 0.001. For second, we are passing 0.8. Then we are calculating here the cross-validation score for this object ElasticNet with the diabetes data set with the 10-fold. And here we are printing the score of this cross-validation score function and mean of this. So if you run this code, you will find here these are the 10 different values of the 10 folds of the ElasticNet model, and here we are getting the mean of this accuracy. So if you compare this accuracy with the lasso accuracy, student, my lasso accuracy is 46.28, and here for the ElasticNet you are getting 46.35 accuracy. So again it is improved here, right? So there is an improvement in the ElasticNet model as compared to the lasso model. So if you observe, this accuracy has increased little bit again with ElasticNet value. So again it is your job to find out the best value of this alpha and L1 ratio in the ElasticNet to find the best model. So this accuracy may increase by trying the different values of the alpha. So whatever values I have taken here for the alpha, this alpha, my accuracy is this. Right? Then here is the model for the ElasticNet Cv. So again, instead of passing the single alpha, here we are passing the set of values for the alpha parameter and set of values for the L1 ratio parameter. Right, then we have fit the model here for the ElasticNet Cv, and if you execute run here, this indicate that my model is executed successfully. Then you can extract the best value of the alpha and the L1 ratio using this inbuilt parameter which is defined under the ElasticNet Cv object, right? So here you are getting 0.001 and 0.8. These are the optimal values for this alpha and L1 ratio. Here, do not confuse student. Many students confuse with this name. Actually, as we discussed in the reach and lasso regularization technique, right? My reach is based on the L2 norm. So for the L2 norm penalty term, my variable is here alpha underscore, and for my L1 norm, that is lasso regularization technique, my alpha parameter is represented by this spelling, that is L1 underscore ratio underscore, because there should be difference between these two values. That's why they have changed this name here, right? And these are the two values we are getting optimal value with the help of Cv here. So when my ElasticNet Cv will build the model here in the feed function, it will take this optimal value from this set of values and then will build the final model. Here we have created the object of this ElasticNet Cv and again printed the score and mean value of the score. So here my accuracy is improved, right? So here my um, code says, here I have done the comparative analysis of these three model or four model. My first model is the linear regression model, simple linear regression model. Then second is my reach score. So I have printed the mean of the linear regression model here. Here I have printed the mean of the reach regression model. Here I have printed the mean of the lasso regression model, and here I have printed the mean of the ElasticNet regression model. So if you run this code, you will get these values of the four different models. So if you observe student, my first linear regression model accuracy is 46.19. For reach, it is 46.27. Little bit improvement is there. Then for lasso, it is 46.28. Again, it is improved as compared to the reach regression model. And for ElasticNet, it is at 46.35 as compared to the reach lasso model. It is improved. So here is the code I have written to print all these accuracies on the bar graph, right? So if you run this code, right, it will print this graph, linear model graph. So we can compare this accuracy with the help of this graph also. I hope student you are clear with all these techniques. Thank you.